Welcome, girls. It's Mrs. Scales here to teach you about energy today. This is the second to the last lesson for the school year. I know you're very excited to be done with online courses. I know they're not as fun as being at school. So let's go ahead and get started today. All right, so the first thing we're going to go over is what is energy. Energy is your ability to do some kind of work or cause some kind of change. For example, we use energy for outlets. We use our energy whenever we ride our bike or go for a walk. Energy does transfer from object to object. It's never lost. So that is one big concept that you're going to learn in this lesson today. One little side thing is that energy is measured in a unit called joules. And it's right here at the bottom of your screen, Joules. All right, so the next thing I'm going to go over with you about is the difference between kinetic and potential energy. One thing about all objects is that no matter if they are still or moving, they have some kind of energy. To show you in this picture, for example, she is holding a bow and arrow. The arrow is not actively moving, so it has potential. It's got stored energy. We all have potential energy. We all have this energy that's stored inside of us. Every single object has potential energy. For example, I have like a candle just sitting right here. When it's sitting on my table and not moving, it has stored potential energy. Now, once something starts moving, we call that kinetic energy. So when, for example, if she releases the arrow from the bow and the arrow, it switches to kinetic energy. Also, if let's say my candle was to fall off the table, it goes from having potential energy to kinetic energy. So kinetic always refers to motion and is the energy of being in motion. Let's say you're riding your bicycle. Potential energy is always stored energy of something that is being still, something that's not actively moving. All right, so to give you an idea of how to use these two terms together, let's say you have a ball in your hand, just like how this picture shows you. That ball, and even the person itself, has potential energy. It has potential. As soon as that ball is released, though, that ball is now in motion, so now it has kinetic energy. It has less of the potential and more of the kinetic. Here's two other examples to show you. This rock on the side of a cliff here has potential energy. Once it falls off the edge, then it will be switched over to kinetic energy. This spring has potential energy that you see. Once it's released, it has kinetic. So if you think about like a rubber band is a good example of both types. You have when it's just there and not pulled apart, it has potential. When you pull it apart, you're increasing the potential of it, and then once you release it, it moves to kinetic energy. All right, so you probably have seen a pendulum before. This is a pendulum when it swings back and forth. So what we do, we use kinetic energy and potential energy to show you how they kind of like work on a pendulum. So let's say I release the pendulum right here on this side of the ball here, okay? So I release it there. When the ball is in the mid swing right here, at the lowest point there, it has the max speed that it's going to have. So with that being said, it's in the mid of the motion, so that's the max kinetic energy that it will have. Now, when that pendulum swings all the way over here to the other side, when it's still for, let's say, a few seconds, maybe just like a millisecond, that's the max potential energy that it has. And that's because it's at the highest point there after it's been swung. And plus it's being still. All right, so there are other forms of energy that I want to go over with you. Heat, we call that thermal energy. And if you look beside each of the definitions here, I try to find like a cute emoji or a picture to show you, kind of help you to remember what it is. So thermal is energy, or you can think of it as fire energy. We have chemical energy, which is stored in chemical bonds. Mainly we think about our food when it comes to chemical energy. So that's why I put a lot of different types of foods here. Once the bonds of the chemical energy are broken, it releases that food energy or that chemical energy. The next one is electrical energy. Electrical energy is just energy of anything that has electricity. So lightning, static shock. I know one little cool experiment I used to do when I was a kid, I would take a balloon, rub it on my head to show the static. Sometimes when you shock somebody, that's electrical energy that's coming out and discharging out of your body. So lightning or any kind of static is electrical energy. Also, clearly, when you go to look at an outlet where you plug in your phone charger, that has electrical energy as well. Now, probably the coolest of all these is nuclear energy. Nuclear energy is when we break apart atoms using a process called fission. Nuclear energy, when you split apart the atom, it releases a ton of energy, like you can see right here with this little mushroom cloud. We also use nuclear energy as a power source. Like for instance at Duke Power, we have a nuclear power plant. So the only downside to this is it does produce radioactive waste when we use this type of energy. Now the next one is electromagnetic energy, or EM. This is energy that travels in the form of a wave, like radio waves, microwaves, X-rays, sunlight or UV radiation, and then we have infrared radiation. All of these are electromagnetic in their own way, and this there's actually more to this. For instance, like visible light is on the spectrum too. All right, now one thing that is true for science is that we have this law, and a law is something that has been tested and basically proven over and over and time again. It's sort of like the law of gravity here on Earth. So this is more concrete than a theory. A theory has the ability to be changed by the scientists, but a law is something that's set in place by a group of scientists. And again, it's been tested over and over again. One thing that we keep testing over and over again is that energy cannot be destroyed. We can transfer it to a new object, but we can't really get rid of it. And another problem is that we can't really create it. Remember that everything on Earth has stored energy or potential energy, and that potential energy switches to another type or another form. So energy always transfers. To show you this with a light bulb, we use electrical energy to form the light that you see. And also, if you've ever touched a light bulb, you know it gives off that thermal energy or that heat energy. So energy cannot be created or destroyed. It only transfers from thing to thing, to object to object. All right, and this is called energy transformation, when energy takes and changes its form from one form of energy to another. For example, our body is able to transform food or chemical energy into kinetic energy that's used for motion. We also have our cell phone that uses and transforms electrical energy into electromagnetic energy. So energy always just transfers from one object to the next. So you need energy to be able to have energy, basically. And if you think back to elementary school, you may have learned about the food chain. So I wanted you to get an idea, with knowing this about energy now that it just transfers. All energy we know comes from the sun. That's taken in by the producers, which are at the bottom of our food chain. And then whoever eats the producers, the consumers, will take that energy in, and then the consumers can use that for motion, or if you look over here, other consumers can eat those, and then eventually everything dies and decomposers break it down and use that energy, and then it all kind of starts over from there. Here's some other ways that you may have not really noticed before how energy transfers, and these are kind of like your everyday things that you see. So batteries have chemical energy that's stored. So it's chemical and it's also potential. That's used to light up your flashlight. Gasoline is a chemical source of energy that's used to put in our cars to give it some motion, or we call that mechanical energy too. Same thing with our food. Our electricity gives us energy for cooking our food and also lighting up our homes. And the sun gives the producers energy to store food. All right, so really quick, I want to show you this really awesome experiment that was done. I do not recommend doing this at home. So what these people have done, they have taken a watermelon. They have placed rubber bands, which have, again, potential energy when you stretch them and stuff, around this watermelon. And so they are just taking more and more rubber bands and putting it around the watermelon. So I want you to see this so you can see what happens. So I want you to make a hypothesis on what you think is going to happen to this experiment. All right, so what happened there in that experiment, you got to see how basically we went from having stored energy, that potential energy, to kinetic energy, which was the motion of the watermelon. Pretty cool stuff. So if you want to watch one of your own videos like this, go to YouTube and just type in watermelon and rubber bands, and you'll see where other people have done this too. Alright guys, that's the end of video number 1. There's a second part to energy, so make sure you click on the next link. Have a good day!